Hi everyone, this is Preston and I'm an engineer with Colatosh bituminous geomembranes. This is a short video to share a paper that's been referenced at recent conferences, but we've seen that the author's original message somehow has gone missing. So this paper concerns a mine waste capping layer in which a bituminous geomembrane served as the impermeable liner and the soil cover layer was to be placed over the geomembrane. The project made very good use of site trials and electric leak detection surveys. Site trials revealed that the contractor was not initially screening the cover soil properly, and this resulted in rocks of up to 800 millimeters being dropped directly on the geomembrane. We can see here the scale of the specified maximum rock size compared to what was found in the initial trial. We can expand further on what took place on the site with this white square representing the total area of the capping layer and the red square representing the initial test pad. It was in this small area where the 800 millimeter rocks were dropped and 7 leaks were detected using the dipole method. We've seen the holes per hectare presented looking only at this test pad, but this image makes clear that there might be more to the story. Once proper screening was enforced and the specified rock size was maintained, subsequent test pads were installed covering the geomembrane. Each one of these test pads, represented here in colored squares, produced 0 leaks using the dipole method. Finally, the remaining area of the site was surveyed at spacing which constituted about 1/4 of the remaining area, and this is represented by these space stripes. Here, again, 0 leaks were detected. We can therefore start to make a more useful assessment of the holes per hectare. An obvious option would be to exclude test pad 1 because it was a test pad that allowed for the correction of the out of spec screening. This is, of course, 0 holes per hectare. But we can also take a very conservative approach and include the 7 leaks in test pad 1 compared to the total area surveyed. And when we do this, we get a holes per hectare of less than 1, still a very respectable figure for such a large and aggressive mine capping installation. So a bituminous geomembrane can interface directly with large rocks, but as this paper indicates, appropriate installation controls should be applied and enforced. Site trials and electric leak detection surveys can be a great way to assess the performance of the installer and the materials. It's possible to place very large rocks on a bituminous geomembrane if care is taken to place them individually, as seen in this image. This type of liner can also handle road-based material and heavy haul trucks, as you see here. And a BGM frequently interfaces directly with drainage aggregate. Finally, in addition to site trials, there are various lab performance tests that can be run to ensure good installation performance on site. You can email any questions or comments here to my email. Thank you for watching.